Determining slopes and y-intercept. How can you determine the slope and y-intercept of a line? Well, I wanted to bring a couple things out and pictures and kind of explain a few things. If we can picture in our head kind of what's going on, it kind of helps us to understand a little bit more about what these things mean. First, let's talk about a slope. Now, I got a picture here of a mountain climber, and he's climbing a mountain, obviously. And what do we call the side of a mountain? We call it a slope. And, you know, we've been talking about angles of lines and things like that. So if we were to draw an angle of the line for that mountaineer to be walking on, these are those angles that we've been talking about, the slopes of the lines. And obviously, depending on if he's climbing uphill or he's coming downhill, whether something is a positive slope or a negative slope. So we need to remember about slopes and think about that as the slope gets closer and closer to zero, it gets flatter and flatter. So we know that a slope of a line is a flat line is zero, and it'll increase as time goes by, increases to the point where the bigger the number of the slope, the steeper we are talking about the line. So that's one thing to think about with terms of slopes. Now the other thing is about football. Now when we throw a football, so if I was throwing a football from one person to the other, and what happens is that that person intercepts that ball, goes and grabs, and that's what this football player is doing, is he's intercepting the ball. And what we want to be able to do is to look at that and say, okay, he's getting in the way of it. So when he's getting in the way of it, he is intercepting it. He's grabbing onto it and cutting it off. And that's what intercept means. Intercept means to cut off, to hold on to. So we're going to take a look at what slopes and y-intercepts, how they look in terms of graphs and in terms of tables as well. But first we need to concern ourselves with the formula, the slope-intercept form of a line. Well, first we talk about y equals kx. We've been talking about y equals kx before, where k is a constant. And we've just been talking and saying, hey, we now know that constant is a slope because slope is a number. Our new equation now deals with something floating out here to the side, plus b. When we were talking about proportional relationships, we were adding 0. And because we add 0, we don't really talk about it. But now that we're adding b, we're adding some number out there that becomes non-proportional. So it's real important for us, as we are describing non-proportional relationships, to be able to use this equation and understand what each part of the equation is. So we have these four letters, y, m, x, and b, and I'm going to go through all of each letter and explain where they come from and what they mean in terms of the graph itself. Now, the x and y represent ordered pairs. So all the ordered pairs that are on the line can be plugged into this formula or this equation, and that would be considered the ordered pairs, the x and y. And to remind ourselves that we know this is what an ordered pair looks like, points that we use to make the line. Okay, the m represents slope, and we've talked about how m represents slope already, rise over run, or what we like to call the rate of change. So that leaves the new letter, which is b, stands for the y-intercept, or the initial change in the real world. If we had a real world problem, it would be the initial change. And this is where the graph is crossing the y-axis. So what we're going to do is we're going to be able to look at a situation and be able to find the slope and the y-intercept and be able to write an equation of a line, because that's all we're looking at this stage of the game. So here we have a graph, and we have a graph of a line. And we can see that this line is crossing in a couple of places. It's crossing here at 0, 1, and it's crossing here at 2, 0. Now, in order for us to find the slope of the line, we're going to use slope formula. The changes in the y's divided by the changes in the x's. And what we're going to do is we're going to replace these y's with numbers as the same thing with the x with numbers. So we're going to circle the y values, which is 1 and 0. We're going to put that up on top there in the numerator. 0 and 2 go in the denominator. When we go to simplify this down, 1 take away 0 is 1, and 0 minus 2 is negative 2. So we're talking about a slope of 1/2. Now, if you wanted to do rise over run, because it is a graph, and you could do that by drawing a triangle. Let's do that as well. Okay, we know that it has a rise of 1 and a run of 2. So again, if you were going to write 1 over 2, but you have to remember, this is a downhill graph as we read left to right, so that's what makes it negative. So it'd be negative 1/2, and that's our slope so far. Now the other thing we have to look for is what we call the y-intercept, and we're going to use the letter B for that. All we have to do when we're looking at a graph is look at the graph. Looking at this point right here, the y-axis, where it's intercepting it. And it's intercepting it at positive 1. So we're this far now. We know the equation we want to write is y equals mx plus b. But what we have to do is to change numbers. So for the m, or the slope, we're going to put that negative 1/2 in that slope spot. And then for the b, we're going to drop that in right there. So really, our equation should read y equals negative 1/2 x plus 1. Now, just so that everybody understands how that's going to work, I'm going to grab myself another line here. I'm going to put one here so that we can talk about it. And I'm going to give it the exact same slope, but change it a little bit in color so that we can have a little discussion. So here we have the exact same line. I made it blue this time. And it still has a slope of negative 1 over 2. So we're going to keep that for our discussion. So here I've moved it, and we can see that it's crossing at negative 4. So what that would do is change this plus 1 to be minus 4. Then our equation would be y equals negative 1/2 x minus 4. If I moved it up here, it would be y equals negative 1/2 x plus 5. If I put it there, y equals negative 1/2 x plus 3. Down here, y equals negative 1/2 x minus 6. And if I put it right smack through the origin, right there, we would say plus 0, or I wouldn't include it at all, and it would just be y equals negative 1/2 x. So we want to remember this a little bit for our discussion, that we notice that only this part changes. That's the y-intercept. That's what we want to be on the lookout for. So you should be able to find those two things. Now let's take a look at it in terms of a table. Now, we've talked about rise over run, we've talked about formula, so now let's talk about the change in y and the change in x. We know that this is also the formula for use in finding slope. So let's talk about change. So when it changes from 2 to 4, it's 2 spaces. 4 to 6, 2, 6 to 8, it changes by 2. Let's check the change in y. The change in y is by 10. 22 to 32, 32 to 42 is 10. And 42 to 52 is also 10. So here we have the changes. What we need to do is take that change of y, which is 10, and that's our slope, right? Change of y, which is 10, and divide it by the change of x, which is 2. We're going to simplify that down. 10 divided by 2 is 5. So we're going to say the slope of our line is 5. Now we need to find the y-intercept. And if we remember, I'm going to go back here for a second. We remember that this point, this one is this point here, and if I showed you this one here, this would be 0, negative 4. What they have in common is the fact that they both have a 0 in the x spot. That's what tells us it's on the y-axis. So when we're looking at a table, we need to find a 0 in the x column, and there's no 0 there. So, but we notice that it's changing by 2, and if it goes 8, 6, 4, 2, 0 would be the next logical thing. So if it changes by 2 here, that means that we need to change by 10 to get this number. And 22 take away 10 gives us 12. So we can see that the y-intercept, or b, is equal to 12. So once again, when we're talking about the equation, if we're saying y equals mx plus b, all we have to do is take the m and replace it, take the b and replace it, and we have an equation. So we would end up with y equals 5x plus 12. So that's an example of with a graph, and now with a table. So now let's talk about real life problems. And in real life problems, sometimes some things occur, and where does all of this tie in? So let me show you a quick little 14-second video, so hang tight. Okay, let's see if I can get this to go. Okay, so there's a quick little video in my yard of a water can or a trash can, and it was leaking, and we need to figure out what our leakage ends up being. So here we go. We've got that an unused trash can is being used to hold 18 gallons of water for watering plants. There's a leak in the trash can. The table below shows how much water is left after the specific amount of time. What can we do to figure out when it will be totally empty? Well, what we're going to use to find out is our rate of change. And we know that our rate of change is basically our slope. So we're going to find the slope of this line. So when we look at this, our change in x happens to be 5 minutes each time. Our change in y, or our gallons of water, happens to be going down by 2 each time. So if we were to write a rate of change, we would say that we are losing 2 gallons of water every 5 minutes. And that's what this negative 2/5 represents. That's our slope. That we're losing 2 gallons of water every 5 minutes. Now, we need to figure out what our y-intercept is. And remember, y-intercept stands for the initial change in a real-world problem. Well, we started out with 18 gallons, so our B was 18. Now what we can do is tie this all together by writing an equation with this. Y equals negative 2/5 x plus 18. Now what I'm going to do is take this and just kind of hold this idea off for a second. And let's talk about, if we didn't know how to do an equation, what could we do to speculate how far this goes out, or how much time it'll take to be totally empty? Well, if we know we're losing 2 gallons every 5 minutes, how many gallons are we losing in 10 minutes? Well, we're losing 4 gallons. So at 10 minutes, that would put us at 30 minutes. Losing 4 gallons would put us at 6. Now, I know that 2 can go into 6 3 times. So in order for me to lose 6 more gallons to get to 0, I'd have to do 3 times the amount of time. So 3 times 5 minutes is 15. And 15 and 30 give me 45. So it's going to take 45 minutes for that entire barrel to empty out. Now let's talk about being able to do this via algebra. This is a little premature for us, but I think it's good for us to see it, how it works, so that we're able to do it when the time comes. Some of you may remember some of your ability to do some equations. Okay, so the first thing we're going to do is we got to set up the problem. So we want to know when the water gets to 0. So we're going to change that y to be 0, negative 2/5 x plus 18. And we're going to find out how much time, and that's what x represents. X is going to represent the time, and this is the water level. So we want to see how much time is it going to take for that water level to be 0. So the first thing we're going to do is we're going to subtract 18 from both sides. Keep it balanced, and 0 minus 18 is negative 18. The 18s go away, and we're left with negative 2/5 x. Now, if you remember about how to get rid of a fraction, you should remember to multiply by the reciprocal, because the opposite of multiplying by negative 2 is dividing by negative 2. The opposite of dividing by 5 is multiplying by negative 5. And what that does is reduce that whole thing to 1. So that way this whole right side turns out to be 1x. When I multiply the left side by that same fraction, because what you do to one side you must do to the other, and then I start to simplify, I know 2 negatives make a positive, and that 2 can go into 18 9 times. And I get 9 times 5, and that's 45. And that represents the 45 minutes that it takes for our water level to get to 0. So that's a little bit of algebra looking ahead. So hopefully you've learned a little bit more about slope and y-intercept and how to determine it by looking at a graph or by looking at a table.